All right. Good evening, everyone. Welcome back to our session on blockchain concepts. So last week we talked about cryptography, the Ethereum framework, and how to understanding smart contracts. So we continue today. All right. So I'll hand over to our instructor. Over to you, sir.
All right, hi everyone. Good evening, good morning, good afternoon, depending on where you're coming from. All right, so happy to be doing this again. So last time we talked about cryptography and the powers of cryptography in securing the blockchain. We all know that blockchain is all about um, security and decentralization. So while we are keeping things decentralized, we are not neglecting the security aspect of it. That's where the cryptocurrency comes in. I hope we are following these classes and doing the hands-on and the resources. All right, so today we'll be jumping into Solidity. Solidity is the programming language for writing on the Ethereum platform. So if you know JavaScript, they are pretty much similar. Solidity and JavaScript are similar. All right, so having said that, I'll be jumping straight to a platform where we'll be following the primitive methods, classes, how to write the tools to write Solidity. All right, so I'll be sharing my screen. All right, so you're on this platform or this website selected by example.org. This is a very nice starting point or a very good resource for anyone that is interested in learning Solidity. They cover pretty much from the basics to the advanced Solidity program. All right, just like every other programming language, we usually starts with Hello World. That is going to be our starting point for today. How to write your first Hello World with Solidity. All right. First and first, once you open a program to write your Solidity, Solidity could be written with, you can write your Solidity on Remix, that is online editor. Just go to remix.com. I guess I'm right, .com. Remix.com. All right, so it is remix.ethereum.org. So I'll be sharing the screen. So once you enter remix.ethereum.org, you're going to see something like this on the screen. As you can see on my left tab, we have
Okay, we can't see your screen, sir. Your
pardon?
screen is not seen. Your screen is not. We can't see your screen. It's not up. Your screen is not up.
So
Like your screen. You were sharing your screen before, but it just disappeared.
okay, I seen
Okay.
it now.
Yes, it's back up now.
All right, thank you.
That's fine.
Um, so as I was saying, once you look on the left tab, you're going to see some folders, files. So that is where you're going to be creating your. That is where you're going to be creating your Solidity files. You organize your folder just like every other editor. All right, so I think I'm going to clear. I'm going to clear everything there. Why are they not deleting? This is obviously a bug. So okay, the purpose of deleting this stuff is for us to have a distraction-free interface. I'll go ahead and delete this and rename it. Um, I'll call it day 3.sol. I guess this is day 3.sol. I'll clear the content. All right, so let's by example, hello world. I'll copy the code and paste and I'll explain. All right, so when starting a selected program, the first keyword there is contract, followed by the name of your contract. So in our own case right now is hello world. You do your normal curly braces and put your statements inside the curly braces. But before the contract keyword and the hello world name of your contract, there is this thing here on line 3. So that signifies that's like the type of the version of the Solidity these people are going to be using. So right now we are on 0.826. The compiler will compile to that version. Some features are not available in some versions, just like updating a software. By the time they keep on upgrading, updating Solidity, yeah, the numbers increases and so they add new features. All right, so this is pretty the editor canvas or the your playground for writing Solidity online using Remy's editor. How do we run it? We run it by hitting this green button here, this button like play button, or there's a shortcut to compile Control S. You hit your Control S to compile. So we're going to be using the button to compile this code. So as you can see, when it gets compiled, we have our on the left tab, on the left bar, we have hello world underscore metadata. So these are the information that explains this program. Then we also have hello world.json. So I was playing the JSON file. The JSON file is for a user that wants to interact with this smart contract to understand what the structure of the smart contract, what the program will written. So that was they call it. So inside it, there's a very important data structure or very important data that inside is hello world.json, which is called ABI. If I hit control, or if I find ABI, I thought I was on Windows. All right, so online 3355. Let me use me. Online 3355. You can see ABI. That is an array. So inside that array, we have we have an object. So this is actually JSON, not. So we have the first item that inputs an array name, greet. Then the stuff will be outputting a kind of the name is will not give a name to associate with the output. Then the type of what we created is string, an internal type string. So this is like when you are interacting with this smart contract, this is what you need ABI. So if you're a front end person and you want to interact with our Hello World smart contract, you'll be asking for the Solidity developer, the ABI. So when you're asking ABI from the Solidity developer, this is typically what you'll be expecting as a front end developer to work with. All right, so you don't need to know how the program was written, all you just need is the ABI. So as a front end developer, as someone that wants to interact with a smart contract, it's very important you understand the structure of. So once looking at it, you could just. So this is a very pretty simple example for getting started. All right, so back to our hello world example. I thought I deleted these stuffs. Okay, these are artifacts. I not delete that part. All right, so back to our the tree. So we have written hello world. So at this point in time, we could advance to the next level. So before we advance, I think it's very important for us to take note of the syntax, the semicolons, the quotations, and the curly braces. Very important. So the next on the list is um, are we seeing my screen?
Yes,
Hello.
yes, you can see us.
All right. All right. So the next is first app. So the app we'll be creating with this example is called counter. So the idea is you have your inputs, you have your outputs, that is getters and setters. So your setters will be incrementing or decreasing, then we'll now use a function called gets to get the value of the count. So at every point in time, we'll be getting the state of the count using this method called get. So as you can see, just explained previously, when you want to write a smart contract, you start with the keyword contract. So what it basically means, you can't use this contract is reserved. You can't just use it anyhow. We only use it when we want to create a smart contract. All right. Likewise, I'll copy this and I'll paste it on our Remix editor. I'll compile again. I'll compile this. So when you want to compile, you come to this tab. You can compile from this tab, Solidity compiler, compile contract. You can compile and run scripts. Right. Then let me also use this opportunity to explain, like I said before, so these are compilers, different versions. If you hit the drop down, you're going to see the one we are using, 0.8.26. So these are the commit hash, they have done some improvements. They started from 0.01 up to this. All right, so this could be a bleeding edge, version. Maybe they're not stable. That's why they resolved to this. Then the next is you can click this button to auto compile. So as soon as you're writing a Solidity, you don't need to do control compile, that's control save. To go auto compiling. You can use this guide to hide warnings. All right. So advanced configuration, I think we should leave this for now. So aside using Solidity on this premise, I think there are other the other languages. Maybe a compiler did not enable that feature. Okay, compiler configuration. You can compile with YOL. I'm seeing it for the first time. So these are different, if I read about, these are different versions of EVM to compile to. So the next tab is also for deploying. Is for deploying. So you can't deploy without compiling first. You need to compile your program into a bytecode. The level EVM understand the is a language the EVM understand the byte. They call it bytecode. So this compiles to bytecode. Then after compiling, you deploy. So you could choose an environment to deploy to. You put your account. All right. So very importantly, I think I like to mention there are different ways you could interact with your program on this premise platform. Uh, you could use right now. I think we are using this guy, premise virtual machine. So you could use your injected provider. So when you use your injected provider, MetaMask, you can now use your real wallet address to interact with this, compile and deploy. But right now we are using a pre-populated accounts to compile For instance, if I hit on this account, under this account, I hit the drop down, you're gonna see different accounts up to I think maybe 15 or 20 accounts already funded with 100 ether. So these are just like test nets or test token. They're not real assets. For instance, I could choose this first guy that ends with DDC4. I choose it as my account. Since I've compiled, so this is the submission gas, blah blah blah. I just do deploy. So deploy with contracts as a counter. So under this dropdown, you could select. So if I've written a several solidity, you could just select the very particular one we want to deploy. So since we have only one on our left panel, we can just go with that. Then hit deploy button. Since this guy compiled icon is showing green, I don't think we'll have issue. Yeah, deploying. So since we have deployed under this place, you're gonna see deploy contracts. Did that guy deploy? Why? I think it deployed. Yes, it has deployed. Now, if you check on the console, we're gonna see this green check is you can hit on it. I'll see the transaction hash, the block hash, the status. So the status is transaction mined and execution. You can see it here. Execution sources, transaction hash. So this could, if you deploy this on mainnet or testnet, you could copy that hash and see, and also see more information on the Ethereum Explorer. So we have deployed, and under the deployed section, deploy contracts, I could open up this guy, this UI. So you could see those functions we wrote: decrease, increment, count, get. All right. On our program, so let me explain this program before I come back to this. So we wrote a contract counter. So the first one we wrote was in 256 public count. So this is the state, or uh, because once you're incrementing and decrementing, you're gonna hold it. So the smart contract, so this is kind of like the internal storage for a smart contract. It will be holding whatever we're incrementing, decreasing on this count variable. So the type is uint 256. So we're gonna get to types, see different types. Then the visibility is public, and the name of the variable is counts. So let me quickly explain. Let me explain this public. So public means any program, any method can see it. Is open to the public. Yeah, just like the name implies. It's open to other programs. Once we export this counter smart contract and employ it in another program, the program where you are using it will should be able to access this count. That's what it means. All right. Then the next stuff we're going to look at is function to get. The visibility is public. View means we're not going to tamper with. We're not going to edit this guy, this count. That's what view does. It means get and don't do anything else, just for viewing sake. Then what is this method returning? If the method is returning anything, we use this keyword returns. What is it returning? Is returning you int 256. Remember this count where it was initialized, the type is 256. That's why we're also returning 256. So this is the estimation of the gas is going to use. So with time, when we are get advanced, we'll learn how to write smart contract that will take less gas to execute. All right. So at the end of the day, we are returning count to basically this function is to function to get the current count, while this one is for incrementing, while this is for decrements. So incrementing is just at one each time we hit or call the inc function, you just add one on what was there before. All right, I think at this point I would like to state that once you define something like this, you in 256 public counts. So what it means, the initial value is zero. Also, the same way when we instantiate something like a Boolean type of data, the default value for that type of data, Boolean is false. Yes. So when we instantiate a in, in 256 kind of data, I would not explicitly assign it a value. It will just get zero as an initial value. So what it means, if we call, yeah, if we do get, we've not we've not done decrement, we've not done increment. Once we just do get, we can see we'll get zero. So why we are seeing this stuff on the log is because each move you make on interaction with this smart contract is a transaction. So the transaction requires, you know, this kind of data. You need to know the set of your data, the transaction hash. So when you are sending money to someone, it's transaction. When you are getting money, it's transaction. When you are doing anything on the blockchain, it's transaction. So we are allowed to do whatever we like on Ethereum blockchain as long as we are able to pay. Yes, but not everything is payable, and not everything is payable. If you do this kind of stuff, you're not going to pay. Yeah, you're not going to pay anything because you're just reading. All right, so your initial value is zero. Can we decrease? I don't think we can decrease. Why? Because of that's the essence of this u in front. I think if I try to decrease that guy, because we can't go from zero to minus one. If I try to decrease it from this zero, I think we should have error. So let's go. Yeah. It says transact to counter the decrease error occurred revert the transaction has been reverted to the initial state. Note the call function should be payable if you send value.
You can't see this particular screen I am talking about.
What have you been seeing since? Sorry. Wait,
First application, that's what I'm saying.
pardon?
First application.
First application. Wow. Wow. But okay, sorry about that. Okay, I was saying, yeah, I was saying we can't decrease because the default value is zero. Once you instantiate you in 256 kind of data and you don't explicitly give it a value, the initial value is zero. Then the essence of this U in front of U means unsigned, means it can be negative. All right, so since we have, so when I call that get, you are receiving zero here, you are receiving zero. Then and I try to, let me clear the console. How do I clear this console? All right, so I now once I try to do decrease from zero, you can't get minus one. That's why we are having this error. All right. All right. So let me do increment. I say is successful. If I do get, we'll have one. If I increase again, do get, we'll have two. If I do decrease, do get, we'll have one. Count will just give you the current states of the count variable. All right. So this is basically it. So as a way of recap, to compile, we use this tab. Then after compile, we now deploy. So we deployed. That's why we're having this smart contract. If we do not deploy, we will not have this information under smart contract. So let me delete it. So to delete it, I just remove it. So for us to have it back, I need to. So this time around, I want to. So as you can see, the account I deployed with reduce because to deploy, it takes money to deploy. The rest still have their 100 ether intact. If I want to use my injected provider, which is MetaMask, I will just come over here and use injected provider. So you can use injected provider, Remis VM mainnet, Wallet Connect, Hard Hat. If you are using Hard Hat, our previous class we talked about framework, for writing smart contract, talked about Hard Hat and Foundry. So these are the frameworks for development. So if I have a Hard Hat installed, I'll just use Hard Hat from here. But let's use let me use my MetaMask and switch to testnet. So I want to work with testnet, Sepulia to be precise. Let me check if I have some token. All right, so I have 0.05. I don't think we are seeing this right now. All right, so let me use injected provider MetaMask. I'll select it. As you can see, yes, I have 0.059 ether on this account, 0.05939. Right, so I'm going to use that one to deploy this time around. So when I deploy, it's going to get decrease because I'll pay gas. So I'll go again and deploy. My MetaMask is supposed to pop up for me to sign the transaction. Okay, MetaMask popped up, but I don't think you guys can see it. So I hit confirm. So contract deployment confirmed. All right. So this is it. So this is not on my machine right now because I deployed to I'm using base. I deployed to base testnet. So whatever I'm gonna do here, we're gonna see it on base live. All right. So let me increment. My MetaMask is gonna pop up for me to sign. So because right now I'm no longer dealing with, you know. So let me share this tab so you see. Hope you are seeing this tab.
Yes, you can see it.
All right. So it's a request from Remy's. So it's going to show you the website you're interacting with. Interact with blah blah blah. This is the smart contract address. Network fee $0.01. Is it cheap? Market speed. You can increase the speed by paying more. All right, so I'll go ahead and confirm. So when I confirm, everything goes where.
Okay, you've stopped sharing your screen now.
Okay, yes, I'm back to Remy's. Sorry about the back and forth.
All right, sir.
So can you, my brother lost connection to your screen share audio.
All right.
Then this is a bug. I'm supposed to see the tab to connect to share this screen back. I'm no longer seeing it. So how do I get it back?
Um, I don't know. I would have said you should refresh. Maybe that will work.
Restart your browser if this continues to be a problem. Restart your browser if the browser has lost connection.
That
So,
probably refreshing is slow.
so why did you lose connection?
That I can't really tell. It's internet. All right. So, guys, just a short break. I'll be back. Sorry about the glitch. Yeah. I'll come back, sir.
All right. Um, it's bound to happen when you are given technical tools for technical issue to happen. So I have to remix open. So I'll.
Okay, your screen is back up now.
All right.
So we can continue.
All right. All right. So that stuff, yes, it was successful. So if I do get, I can now see one on the screen. So I'm gonna do something right now. I'm going to expand this guy, copy the transaction hash, which is this guy. I'll copy it and I'll go to base. I'll go to, I'll search for base explorer testnet. All right. So I'll paste that transaction hash here. I'll search for it. So guys, as you can see, this is a base separated network testnet transaction only. So you can see the transaction hash I pasted. The status is confirmed, is success. The status could be success, confirmed, finalized, whatever, whatever. There are different status. All right, confirmed by sequencer, blah blah blah. When did this happen? 4 minutes ago, today. So you can see the actions. So you can see the address. So you can see the address where the transaction came from to this smart contract. So this address this is on this, from this address to this address. So green ticks means it's completed. Value is 0.8. It's not up to. I think it's a kind of very low transaction fee. All right. So this is the gas price. So you can check the state too of what you did, and a set of information that represent the current state is updated when the transaction takes place on the network. The blue is summary of those changes. So this is like the movement. Producer to this account, this is the balance. So everything on the blockchain is open. Anybody, if any person has access to your public address, the person can see how much on your account. So you can see before on this account before what he has 0.05933. So after that, so this is before this happens. So after that transaction, the person now has 0.593931. It has decreased a bit. So this is state difference by this. All right. So if we dig in deep into this person's account, you can actually see what the person has, the movement, when he sent money, when he received money. You can see the whole history of that account. Yes. So this is history about this guy. About this guy. It belong. Yeah, it belongs. I use this account. 118 days is like 4 months ago. All right. So if this was, I give him a minute, what address will be? Say, oh, this boy don't hammer. If you see my transaction footprint, so just so we know that blockchain is an open place and also decentralized. All right. So back to our program. So we succeeded in writing Hello World, we also succeeded in writing a counter smart contract. I think we just speed it up from here and explain the rest. So if we don't get anything out of today's discussion, at least we've learned how to create a simple smart contract by using the keywords, supplying the contract name, and sticking to the syntax. And at the very top of our smart contract, we'll put in the version, we'll license it, and also put in the version. All right, so let's head over to primitive types. So what are primitive types? Every programming language uh, have their primitive type, but across the board, they're basically almost the primitive types are basically similar, like things like boolean, numbers, string. So for solidity, the primitive types looks like this boolean. So these are just the basic stuff you could use to write stuff on smart, with solidity. For the most up to date, okay, you should see this. Here we introduce you to some primitive data types available in solidity. So have boolean in 256, int 256. So this int means it can be minus or plus. That's why they did not have that difference between you int and normal int. So address is it could be your externally owned address or smart contract address. Right. So these are the types listed. Boolean is either true or false, 0 and 1, high and low, black and white. So those are Boolean. All right. So U stand for unsigned integer, meaning non-negative. Yeah, we'll explain this. We have U int 8, we have U int 256, we have U int 16, U int 32, and so on. So when you want to write things like one, it's better you use U int, those single digit stuff. You better use U int 8 because when we use like when we apply U int 256 on this value, it's gonna be like over k. And that's why I say there's the way we write a program, it consumes more gas. So when you use in 256 for stuff, you could have used U8, it consumes more gas during interaction. All right, so uint is an alias for uint 256. You could use uint. Maybe when we don't want to use uint 256, once you use uint, it also means uint 256. You have int 8. Int 8 means it could go positive or negative. That's why int 8 will have -1 here. Then which other stuff worth mentioning? We have address type. We want to use your wallet address or user's wallet address or smart contract address. We use this type, address type. Okay, like I mentioned before, you can see unassigned variables have a default value. When you don't assign like boolean, when you don't assign it a value, the default is going to be false. In 256, like we saw on the counter program, the default was 0. On in 256, default is 0. Then when you do address, I don't give it any value. The address will have this. So variables. We're gonna stop today on a constant. Then we head over to at our future. We're gonna head over to Solidity by example.org and look at other types, other functions, and what we have on the website. We're gonna use it as our hands-on, as part of our hands-on. All right. So we're gonna call it a day on constants. All right. So we are on variables. So there are three types of variables in Solidity: local, state, and global. Like I said earlier, when you use when you misuse this variable, the scope, it could cost you more gas than expected. All right. So like variables will have local, states, and global. Local is when you declare a function and you have a local, you declare a variable inside that within the scope of that function. That, excuse me, that variable could be said to be local because it doesn't it doesn't exist after the function is gone. So declared inside a function, not stored on the blockchain. Yes, it's not stored on the blockchain. Heading back to our program, I want to show us our first app, which was Counter. This will be stored. This is a global variable because it's not inside any function. So it will live forever on the blockchain. This counts. So anytime you go to the blockchain and check, you're going to see the state of the count. So that's what we mean by global variable. So state variable also declared as a function and stored on the blockchain. Global provide information about the blockchain. Sorry, I think I made mistake. Global variable is something like what I showed us before was state variable. Global variables, they're like inbuilt in Solidity when we have things like um, we want to know the person interacting with the smart contract or have a message of sender. Yes. What message of sender is a typical example of global variable, and it means the address of the person calling a function or the address of the person interacting with the smart contract. All right. Also, we have a block.timestamp is a global variable. So global variable provides information about the blockchain. We want to know you know, get information about the blockchain, use a global variable depending on what you are looking for. The state variable is defined outside a function and it lives on the blockchain. So constant from the name it means variables that cannot be modified. When you don't want your value to change in a program, we use constant. Something that cannot be changed even in future on the blockchain. So how do we make use of constant? We make use of constant by using the constant keyword before the variable name. Like it is written here, you have address, the address is public and it's constant. So this is the type, this is the visibility, and this the it's an assignment. Let's go and check this third guy. What is it called? Yeah, we know it's constant, but on this third declaration, like we said, this is the type, this is the visibility, the place we are using the constants. All right. Uh, it's nice having us on today's session. Hope we learned things about Solidity. As a way of recap, we could get started with Solidity on premise.ethereum.org, online editor, very nice. Then we also saw the basic syntax of Solidity, and we wrote our first program, Counter, which has the functionality of increments, decrement, and getting the state of the counts. We also saw different primitive types like address, UN256, and the rest. All right, Mr. Damilare will be dropping the resources and the hands-on exercise. All right, thank you guys.
Thank you very much for joining today. I hope you all learned something new. And so for the resources and the tasks, I'll be dropping them here and on the Discord channel. So I expect you guys to look it up from there and so that you can have access to it. And then you can also ask your questions in the Discord channel if you have anything that you are yet to understand. So everything will be explained in the channel. So thank you very much for joining. Just a little seconds while I share the resources to us with us rather.
All right. Okay, see you guys next week. Need to run off.
All right, thank you very much, sir.
All
See you
right.
next on Saturday. Okay. All right, thank you. See you guys again on Saturday. Bye.